So the digital built environment, what are we talking about? We want you to think of a virtual world in which every single relevant real object has its digital counterpart. And so with that in mind, in about 2016, the Department of Natural Resources and Mines in Queensland, who looks after the land administration, together with the Spatial Industries Business Association, awarded a tender to write the roadmap for 3D Queensland to a group comprising ASL Allen Consulting, who did the economic analysis, and myself, who did the work with stakeholders and developed the vision, and a team of other domain experts. And the first stage was to identify the value for 3D Queensland and the digital built environment. And we interviewed stakeholders right across the property sector, from planning through design, engineering, construction, insurance, facilities management, leasing, sale and so on, as well as local governments, mining organisations, emergency services. And we did a report that's now public in April, and since then we've been working on the second stage to actually develop the roadmap to deliver the vision. This presentation is basically outlining what are the key elements of the digital built environment, the value that we should derive from it, and some of the next steps. So value really comes from fixing a whole lot of pain points, and I won't go into them all because I don't have time, but just about every stakeholder that we spoke to had a whole lot of pain points in their existing processes. Even though we could identify the pain points, it was often difficult to quantify the value until we finally hit upon a very simple question, and that was, if you had the same quality 3D data, including boundaries related to existing conditions that you have at the end of a project, if you had that same data at the beginning of the project, what would it be worth to you? And the answer came back, in the end, quantified by ASL Allen across Queensland alone as a couple of $2 billion. We also discovered, however, in talking to people, there are major risks in developing the digital built environment. We're already creating, as you know, many digital models for design and construction, asset facilities management, sales and marketing. More and more real estate agents are using 3D models. These are also being integrated together and connected to sensors, and through them to our power, water, telecoms, utility networks. And the risks to the operation of our buildings and cities from cyber crime and cyber war are literally becoming existential. And the way we can imagine this is that we've seen what happens to Florida and other single cities when a major hurricane hits. But what if every single city in the nation is attacked at once? Who's going to come to our rescue then? And we really do face this existential risk unless we begin to take it seriously, as more and more of our models and sensors and power and water networks are interconnected. Trust is also a major issue that's been identified by the stakeholders that we've spoken to. The question is, how do we ensure trust in the 3D digital world? What are the laws that operate? What rights do they have? People have the rights they purport? What are the responsibilities and restrictions that they are subject to? Is the data correct, and who's certified it? Are the providers qualified to do the work they're contracted to? And what about their professional indemnity insurance? So all of these issues are really important in the real world, and as we move more and more of our activity in the digital, we have to ask ourselves, why is it any less important there? So what are we talking about really is we're talking about federating 3D imagery and models, different types at different scales, ultimately millions of different models under the control of millions of different entities. So we're capturing already through ground penetrating radar and others techniques, underground geology and hydrology. We can image the whole country now at 10 centimetre, even potentially 5 centimetre scale. Infrastructure and services and cityscapes, we can capture in 3D at down to 2 centimetres. Buildings potentially down to a couple of millimetres, and plant and equipment, fixtures, fittings and devices at sub 0.1 millimetre. So all of these models, technically we can now create. We are creating them. And I won't go into these here because you fully understand all of these opportunities, and capturing real data down to even nameplates on individual objects just using photogrammetry. So, and again, then being able to access them on iPads. What we're talking about ultimately is creating these together using building information models, graphical information systems, photogrammetry, LiDAR, as I said, ground penetrating radar. Linking all of those into the real world using the new global position and elevation grids, which we can now get at 2 centimetre accuracy. We can even measure the shift of 7.5 centimetres of the whole continent of Australia each year. We've got then the need to have not just the physical dimensions of each object, but its geo-references tied to that grid. We want to embed all of the legal boundaries, and I'll say more about that in a minute, as well as the addressing, so that we know that a particular company is occupying this particular room on this floor in this building, and it's tied to the model, not some ancillary database. We're talking about private and public and cut by time. So at any particular time, there'll be a set of models that represent the world. It'll never be fully in sync in all places, but it will be in sync where we need it to be, when we need it to be. In terms of the boundaries, we're talking about the admin boundaries such as council boundaries and statistical boundaries, as well as the cadastre, which is the title boundaries, which then lead into contractual boundaries such as lease boundaries and common law boundaries like easements or rights of way and statutory boundaries. Those boundaries can then be linked back to the actual laws which are being digitised to be read by machines, so that artificial intelligence can be used to interpret our rights, responsibilities and restrictions to help users determine compliance and so on. And Data 61 has a project which they say they've already been able to have artificial intelligence interpret 60% of our laws 100% accurately. The other 40% they struggle with, and if the machines are struggling, then it's no wonder that people struggle with the laws. So, but we will be able to link those in, as well as all of the related information. So we'll name the object or feature, and then for a manufactured object, a supplier, materials, parts, price, operating instructions, warranty, maintenance history, real-time sensor, who owns it, controls it, operates, maintains, leases, finance and insures it, etc. So all this information can then be locked by the data provider against change so that we can rely on it. And more than just the information, we need to be able to certify the boundaries and the dimensions of the objects and the boundaries and compliance with all the laws. So that brings in the need for the authorities to certify that this particular model is compliant so far as planning and building regs go. Our surveyors, fire services, engineers and others can certify their parts of the model. The same with commercial interests relating to finance and leases, and then the registries, the land registries and so on. All that information needs to be locked against change again, and we're investigating the opportunity to use blockchain to manage those certifications and enhance the trust environment. It means ultimately creating a platform of some sort that is distributed, where each of the owners of the asset controls the data that represents the model of that asset, both public and private. So you've got underground, you've got state topography imagery, cityscapes, infrastructure and services, individual building models and others such as every single device, like was mentioned before about Rolls-Royce engines. General Electric is looking to create the digital twin of every piece of equipment. So this provides the platform that needs to be highly secure. If we're going to build this virtual world, we need to make it as secure as we possibly can, and it ought only to be subject to the laws of our land, because we've already seen where data held, New Zealand businesses had data held offshore, frozen under a legal suit taken in America, had nothing to do with those businesses, but it froze the servers on which their data was held, and they couldn't operate for 3 months, put most of them out of business. So we can't afford to have our whole integrated 3D world that's connected to our cities and managing our power and water supplies held in servers where it's subject to control under other countries' laws. Having the data held, though, of course, we need to know who has access to it, which means we need to know, just in relation to your bank account, nobody can just go into your bank account and open up. We need to know who it is, what role you have, and what are the permissions that go with that role. And they will ultimately flow from the legal entitlements that we have in the real world and which are embedded in the models. Then you can use whatever software you like, hardware, to access the data and to model it and to see an integrated view of your property within the cityscape with all of the underground services passing your property all in 3D. To make that happen, we need standards, and AMCA is really at the forefront of helping develop that metadata, and where we don't have standards, translation tools, so we get a seamless integration of the data sets. In terms of the business model, any commercial entity would be then able to set up, just like a bank is set up to hold our money, these entities could hold the data that represents our built environment and could charge fees for third-party access for commercial purposes. So if you give it to an insurer or financier or a tradesperson to access, then a fee would be payable, and it ought to be much less than the cost of currently trying to get the data that would be available in this new environment, trying to get it currently using paper processes and other means that we have to go through. So there is a business model that will support the development of this underlying infrastructure. And once we've got the data, and this is a major problem, is we've got to have the data to change our business processes. We need our business processes to be working with 3D to create it, and so we're in a catch-22 really, because without the data we won't change our processes. Now, again, many of you are already starting to work in 3D models, but I would be pretty certain that your actual business processes inside your own businesses are not working in 3D. But we will get to a stage where we are conceiving and planning, designing, engineering, testing, costing, communicating, disputing, finally agreeing and approving, all in virtual space. And we'll be interacting via virtual reality, augmented reality, and mixed reality. Once we have got that agreement, we will then execute in the real world using increasingly automated processes, automated mines, farms, processing, logistics, through to delivery, and as I think it was Doug talked about, maybe only 5% on site. We've got to update our models as we go, and more people are understanding that you've got to capture the in-process construction to get a full as-built. And I won't go into these videos other than this one. I don't know whether you've seen it. This is a demonstration by Mark Zuckerberg. He's at a conference, and you can see the audience in the background, and these people are just cartoons, but as he's showing, he's talking, and you can see where he's looking. You can see his emotions and expressions. These cartoon characters are going to become very quickly virtual models and avatars of ourselves that'll be indistinguishable from us, and that raises a whole lot of other problems. You can see he's instantly moved from the stage to a live feed in his office. And here he's just picked up a fencing foil, and the cartoon characters just created himself a sword to use in that mixed reality space. So you can start to think about this blending of the real, the virtual, and the augmented. Now he's heading off to his home, here to check on his dog. So you could imagine, instead of that a dog, it's a person who is working with you on a piece of equipment in that building, and now they're there in front of the equipment physically, but both of you are together in the space talking about it, discussing it, taking a phone call here. So Mark's taken a phone call from his wife in virtual reality or mixed reality, and now what he wants to do is take a family photo, which is a photo in virtual reality of the real space where he's an avatar. You can see he's an avatar and she's on the picture of a phone using a virtual selfie stick to create this picture, which he's now picked up and posted to Facebook, right? So we're going to get to the stage where our children are going to live in a world where the physical and virtual is a seamless blend, and they're going to wonder how was it possible to ever communicate in a purely physical world. So once we've got that and we're now accessing it, what we're talking about is being able to read those models, put new plans and designs back into the database, and then updating those from the real world as built. If we do that, we can do it right throughout the property cycle, through financing, fabricating, costing, right the way through to selling and decommissioning. But importantly, when we've got 3D city models integrated with these individual buildings, we can manage the flow of vehicles and goods and people and power, gas, water, information, and right throughout the building sites and cities. And again, talking to our emergency services and other sectors, they will see key value in having this available to them, as well as in mining, agricultural, tourism, health and safety. I guess it's already been mentioned, induction and training without having to physically go to the site. It means that we can deliver better outcomes socially, environmentally and financially, much more quickly at less cost and with much less risk. So what are we talking about? Well, here's an example, just if you've got your house as a model. You want a painting quote, you give that access, that model to a series of painters. They can go into the model, their software can immediately understand the dimensions. You can say what paint colours you want on individual features, architraves, mouldings, whatever, so there's no mistake. They can make a quote with their software reading the model almost instantly. You've got 3 quotes that you can choose and select a painter. You've seen online all of his references. You make a decision, you sign a contract, it's all done digitally. The tradesperson has never had to go anywhere, they've won the work, and the guy who lost the work, most of it was done by his software, so very little loss. We can then give the model to the insurer and say, this is what we're asking you to insure. The insurer locks it, it's sitting there, and then what happens? You have a fire. Now the fire brigade has breakdown access into your model. They can see where the fire is. It's located in a room that's got some, say it's your art room, got a few dangerous chemicals in there. Normally you've only got 5 to 6 minutes to respond to a fire once it's started burning before it's taken control. If they can see where your house is, access at the back lane, where the fire hydrants are, they can plan all that while they're on the way to the fire. The more likelihood is they're going to extinguish it before it completely engulfs your house. Then after it, they just send up a little drone, fully capture in 3D the aftermath and inside the house. You can then provide that to your insurer. Your insurer then uses, again, costing software and AI to match the damage against the original building, determines a settlement which you can then accept virtually straight away, and you get paid instead of months or potentially years sometimes in disputed claims. So they're just some of the examples, and we only really looked at quantifying in our study for Queensland what the benefits were just in building and construction, a little bit in facilities management, and that alone was billions without all the network effects that I've just spoken about before. And importantly, if we get it right, we are in a position to mitigate our existential risks. And that is a big, big factor that we need to be thinking about. The challenges that we're facing really aren't technical anymore. They're about the data, where it is, the complexity of the laws and the terms of use, unknown data quality, lack of indemnity, who controls the data for monetisation. Also, our processes, as I said, are largely 2D, so 3D data is not valued. Once the project's finished, it's handed off, and yes, there are some sophisticated facility managers who may be now thinking about taking the data on, but if you look broadly across our whole built environment, most of the people who are managing our built environment can't handle 3D data. If they can't handle 3D data, the people working there have no incentive to upskill to use it. If they haven't got the skills, changing to 3D processes is really hard. And then why curate the data if you can't use it? And so we're in this catch-22 loop. Security and privacy is a major issue while everybody's exposed to the weakest link of who's holding what models connected to what sensors to what utility grids. And we have a problem of market failure because without a common framework to bring all this together, it's impossible for any single firm or organisation to capture the common benefits or mitigate the common risks. So part of what we're talking to government about, and we need your help to sell this message, is that we do need a new legal framework to ensure trust in the digital world. It means defining what are authorised models and what the rights of access are, who the data holders will be, and so on. And ultimately linking it into the electronic property exchange. So finally in Australia we can now transact most properties electronically, so you don't have to physically go and settle. What you can do is sell a property purely electronically. Now if we link that to the model, it means when you sell the property you sell rights of access to your model. So suddenly we don't have to regenerate the data all the time, and each model becomes its own standard, and with a standard you can always improve it. If you're always completely regenerating from you never know whether the data that you've got this time is better than the data you had last time. But if you have got a data set that is the standard, then you can always check and say, yep, this little bit is better, so I'll keep that little bit, and then the next little bit is better, and and so constantly we're improving the digital built environment. There's a number of next steps, and I think I'm running out of time. I won't go through them all. But in the end, at number 6 there, we need to begin to collect the data in a way that can be utilised, because it's like the telephone network. The first few 3D data sets are not going to be terribly useful. But if we store it, and we've got good metadata about it, gradually that data will build up, and it'll get to a stage where businesses can say, hey, this data is really useful. I will now adapt my processes to utilise it. And so we just need to begin capturing this data within a framework that people understand what their rights of access to it are. And the basic principle we're talking about is really building digital infrastructure for the 21st century. And if we get it right, it will be the most important piece of infrastructure we build in this 100 years. And the basic principle that we believe and have had feedback from all the stakeholders we've spoken to, we've got to simplify this. We don't want to have a whole new set of laws that differ council by council, state government by state government, federally, with all different terms and conditions by each organisation that puts it up. If that happens, we will have to employ spatial lawyers alongside our property lawyers in order to understand what are our rights when we're dealing in the virtual world. But if we put in place a very simple principle that whatever rights you have in the real world, those rights should translate into the virtual. So if I'm the owner, I know what rights I have in the building. I know that it's subject to certain constraints. I can't tear it down arbitrarily. I can't turn it into an abattoir. And the same with the virtual world. I might have spent my money building the building, but it's subject to these rights. And the same thing, I might have spent my money creating the model, but it is subject to a set of rights. And as far as possible, if those rights are mirroring, then we don't need to employ another lawyer. And we've then got the ability to maximise the value with the least amount of friction out of the virtual world, while protecting ourselves as best we can from cybercrime and cyber warfare. And yes, that's the message that I have for you, ladies and gentlemen, and I would hope that we can count on the support, as we certainly had it from Sumit, wherever he is, over the last few years, that we need the industries to come on. So the facilities managers are supporting us, the consulting engineers and so on. We need the industries to be saying to government, if this is going to happen, and it is going to happen, it needs to be built in the same way that you are building at the low level, at the level of the standards that you're writing for your mechanical and electrical services. We need the same approach globally. And so that's the hope, I guess, in what we're doing. So thank you very much.